Hello my dear students, in the last class I explained how to draw SFT and BMD for cantilever beam when it is subjected to point load and UDL and uniformly varying load also. Today we will see how to draw SFT and BMD for a simply supported beam with a point load at its midspan. Okay, let us consider a simply supported beam AB of span L carrying a point load W at its midpoint C. Okay, now let us consider this is the beam AB. It is simply supported. Simply supported means it rests on the two supports, right? Here the load is acting at the center. So what you have to do here, first you have to calculate what is reactions. What are the reactions developed? Here reactions at A, support is there. So reaction developed at A, RA, and at B, that is RB. So first you have to calculate RA and RB. It is very simple. Actually, total RA plus RB is equal to W. It is at the center, so you can easily say that it is RA is equal to W divided by 2, and RB is also equal to W divided by 2. Okay, or you can use that conditions of equilibrium, that is what summation of vertical forces is equal to 0. So that means here vertical force, that is upward for RA and RB, upward force is positive and downward force is negative. So if you consider summation of vertical forces is equal to 0, then RA plus RB minus W equal to 0. So RA plus RB is equal to W. So now you have to find either RA or RB. For that you have to use another condition of equilibrium, that is moment is equal to 0. Either take moment about A or B. How you can consider that moment about B? That is I'll consider moment about A. Okay, so summation of vertical for moment is equal to 0. So I'll consider about A. So what it is now, RB into, because this is like this direction, so anti-clockwise, so minus RB into L plus, this is clockwise, like this it's moving, so plus W into, this is L divided by 2, right? So W divided by W into L divided by 2 is equal to 0. So what you will get? You get RB is equal to W divided by 2. So RA also equal to W by 2. So like this you can calculate, you can find what is reactions at A and B. Once if you find the reaction, next step is you have to calculate, you have to find what is shear force and what is bending moment. Let us consider, first we'll find what is shear force. Same thing I have written here, since the load is at the midpoint of the beam, therefore the reaction at the support A is equal to W divided by 2. Okay, now we can see that shear force at any section between A and C, that is up to the point just before the load W, is constant and is equal to the unbalanced vertical force, that is equal to 0.5. How it is explained means, see, let us consider one simply supported beam. Okay, so this is simply supported beam at A, and I'll consider here till here this is B, right? Now this is total length. Okay, this is total length, and this is at the center. Okay, that is W force load. Now this is L by 2. This A to C is L by 2. C to B is L by 2. So you have to find the shear force. Okay, let us consider first the portion A and C. Okay, now this is section X. Okay, which is located at a distance of X from A. Okay, now you can find what is shear force at X. What is that? This is RA and this is RB, right? Now shear force at X. What is that? Shear force is unbalanced vertical force to the left or right of the section. Now I consider left section because X is close to the support E. So if I consider the left side, now this is force. RA is left side upward. So what is that? It is plus. Sign convention of shear force, that is plus. So shear force at X, that is equal to shear force at X, that is equal to, okay, how we can write Fx, okay, that is equal to my plus RA, left side upward plus RA. What is RA? RA is equal to W divided by 2. Now find a different points. First point is at A. What is at A? At A, X is equal to 0. Here there is no X term, so it remains same. At A also it is W divided by 2. At X you already calculated W divided by 2. At C also it is what? W, at C it is again W divided by 2 is there, and this is left side downward, so that is what? Minus W. So W divided by 2 minus W, that is equal to W divided by 2, right? So now that is shear force at for the portion AC. Let us consider next shear force for this portion, that is BC. So again I'll consider one more section XX, which is at a distance of X from A. Okay, now what is shear force at X? I consider this side. First I'll consider this side AC. Next I'll consider the side BC. Okay, what is shear force at X? Shear force is represented by the symbol Fx. So that is equal to, now this is close to support T, so I consider from this side. This is right side upward, that is negative. So what is that? Minus RB. So what is RB? RB is minus W divided by 2. Next find at different points. What is that? At B, X is equal to 0. So shear force also equal to minus W divided by 2. At X, W divided by 2, and at B, what is that? Minus W divided by 2, and here this is plus W, so again it becomes minus W divided by 2. Now you can draw the diagram. How it is? The diagram, so at A it is W divided by 2 plus, this is the baseline AB. Okay, so above the line is plus, below the line is minus. So at A it is W divided by 2, 0.5 W. At C also it is plus 0.5 W. When you consider the portion AC and then consider the portion B, C, at B it is again minus 0.5 W. That's why below the line at C it is again minus 0.5 W. So it is below the line. Join this like this. So this is the shear force diagram. This is SFD. Okay, for simply supported beam when it is subjected to point load at C. Now shear force diagram is done. Now you have to write this. This is minus, this is plus. Then we'll find what is bending moment. Okay, how you can calculate bending moment? Again consider the same section. We'll consider the section. I'll consider same here, this section only at this point. What is bending moment? Now this is about shear force. I'll consider now bending moment at X. What is that? Bending moment at X, that is equal to mx. That is given by bending moment is force into perpendicular distance to the left or right of the section. Now the section is here AC. First I'll consider the portion AC. So what is that? RA into X, and this direction you can see it is like this. So what is the sign convention for bending moment? This is plus, right? This is minus. Okay, so now this in this direction, left side it is clockwise, it is plus. Okay, so shear bending moment at X mx is equal to RA into X. Okay, what is RA? RA is equal to W divided by 2 into X. Okay, now bending moment at X is done for the portion AC. Now at different points you calculate. What is that? At A, what is X? X is equal to 0. So bending moment at A, that is equal to, this substitute here, W divided by 2 into 0, that becomes 0. Okay, next point at X is equal to same. This is W divided by 2 into X. Next at C, what is at C. At C here, x is equal to what? X is equal to, till here, what is the distance? L, total is L, so this distance is L divided by 2. Okay, so x is equal to L divided by 2. So MC is equal to, now W divided by 2 at x into x into L divided by 2. So that becomes WL divided by 4. Okay, now this is the bending moment at C. Then again consider the portion BC. Okay, I'll consider the section here. Let us consider the portion BC now. Now bending moment at x. So that is MX is equal to RB into x, force into perpendicular distance. Again, you can see this direction. The direction is like this. So that is right side anti-clockwise is plus. So plus RB into x, right? This is x. What is RB? RB is equal to W by 2 into x. Substitute at different points. What is at B? X is equal to 0. So bending moment at B is equal to 0. Then at x, that is same, W divided by 2 into x. Then at C, what is at C? L is equal to L divided by 2. So substitute here, x is equal to L divided by 2. Then again you get MC is equal to WL divided by 4. Okay, so now draw the diagram. How you can draw? Same thing I have written here. Okay, in sentence, bending moment, that is maximum bending moment, MC is equal to this equation, WL by 4. Now draw the diagram. What is that? At A is equal to 0, at C WL divided by 4, at B also again 0. So join this line, you get this curve. Okay, triangle shape curve, triangle shape line. This is not a curve, so straight line. Okay, this is bending moment diagram for a simply supported beam when the load is acting at the center. So like this, you can draw SFT and BMD for the simply supported beam when the load is acting at the center. Okay, I hope this is sign is plus, both the side it is plus only, so you can write plus. This is the baseline. If it is minus, you have to draw below the line. I hope all of you understood. In the next class, I'll consider one more derivation when the simply supported is subjected to uniformly distributed load. Okay, I hope all of you understood. Thank you.